There's one fact about the 7.3 Godzilla that decides whether your truck hits 500,000 miles or blows up before it hits 60,000, and it has nothing to do with the metal Ford put inside it. It's not a recall, it's not a defect. It's a decision every single owner makes, usually without realizing it. And most videos about this engine never mention it because it's not as flashy as talking about horsepower numbers. By the end of this video, you'll know exactly what that decision is, why the engine's own design makes it easy to get wrong, and what to check right now if you own one or you're about to buy one. Stick with me, because the reveal at the end is the part that actually matters for your wallet. Let's start with why this engine exists, because that's where this story actually begins. Ford didn't build the 7.3 Godzilla because they wanted to chase a new trend. They built it because previous big engines had damaged their reputation with fleet buyers and truck owners. Before the Godzilla, Super Duty trucks relied on engines like the Triton V10, a design that worked but wasn't built with the same towing-first mentality, and it showed over years of hard fleet use. Warranty claims were high, trust was low, and Ford needed a gas engine platform that could take a beating and keep running without excuses. So the engineering brief wasn't "make it exciting," it was closer to "make it survive." That single decision shaped everything about how this engine was built, from the block material down to the smallest bolt pattern. That's why it's a pushrod design in an era where most manufacturers have moved to overhead cams. That's not Ford being behind the times. Pushrod engines are physically shorter, mechanically simpler, and have fewer components that can fail over time. An overhead cam design needs extra chains, extra tensioners, extra moving parts up top just to operate the valves. A pushrod engine strips that down to the essentials: fewer parts, fewer failure points, and a shorter engine that's easier to package into a work truck without compromising the frame or cooling system. Ford leaned into that simplicity on purpose, because simple, overbuilt parts are what hold up under a decade of towing and fleet use, not flashy specs on a window sticker. Here's the first real engineering fact worth knowing, and it's genuinely unusual. The 7.3 Godzilla uses a forged steel crankshaft as standard equipment, even in base work truck trims, not reserved for a performance package you have to pay extra for. Forged cranks are typically the kind of part manufacturers save for premium engines to control costs elsewhere, because forging steel is more expensive and time-consuming than casting it. Ford includes it standard across the entire lineup. In fact, this crank has proven itself capable of handling over 1,400 horsepower in built engines, which tells you Ford left an enormous amount of margin in a part most owners will never push anywhere close to its limit. That's not an accident. That's a company deciding the bottom end of this engine was not going to be the weak link, no matter what the truck spent its life doing. That crank is held in place by a deep skirt cast iron block using 6-bolt main caps, 6 bolts clamping down on every single main bearing journal, instead of the 4 bolts common on a lot of gas V8s. More clamping force around the crankshaft means the bottom end stays rigid even under heavy load, which matters enormously when you're towing near max capacity and that crank is under constant, repeated stress from combustion pulses hitting it thousands of times a minute. A 4-bolt design can flex slightly under that kind of repeated load over hundreds of thousands of miles. A 6-bolt design resists that flex far better, which protects bearing clearances and extends the life of the entire rotating assembly. This is the kind of bottom-end architecture you'd expect to see on something built for racing or heavy-duty diesel use, not a base-trim work truck that might spend its life plowing snow or hauling a horse trailer. Second fact, and this is the one I actually think is the most underrated detail on this entire engine. The Godzilla uses a chain-driven, variable-displacement oil pump. Here's why that's a bigger deal than it sounds. Most engines run a fixed oil pump that pushes the same volume of oil regardless of what you're doing with the truck. Idling in a parking lot or towing 40,000 pounds up a mountain pass get treated the same way. And that constant output actually wastes engine power and generates unnecessary heat. Ford's engineers specifically designed this pump to do something different. At idle, when the engine doesn't need much oil pressure, it doesn't waste energy over pumping. But under load, higher RPM, heavy towing, hard acceleration, The pump increases pressure specifically to protect the engine when it needs it most. It's an engine that adjusts its own protection level in real time based on how hard you're actually working it, rather than running one static setting for every condition it'll ever see. That's not something you typically find on a production truck engine, and it's a genuinely clever piece of engineering that almost never gets mentioned outside of enthusiast circles, because it doesn't show up on a spec sheet the way horsepower does. So on paper, between the forged crank, the 6-bolt main caps, and the load adaptive oil pump, this is one of the more over-engineered gas V8s Ford has produced in decades. And that's exactly where the real story, the thing nobody talks about, comes in. Because this engine is so overbuilt, it's remarkably good at hiding neglect. And that's not a compliment, it's a risk. A weaker engine will tell you something's wrong early. It'll knock, it'll smoke, it'll lose power, and you'll know to get it looked at. The Godzilla often won't give you that warning. Owners see how tough this platform is on paper and start assuming the engine will forgive shortcuts, stretching oil changes from 5,000 miles to 8, then 10, telling themselves the engine can take it because it's got a forged crank and a fancy oil pump. And for a while, it genuinely can. That's the trap. All that engineering, the forged crank, the reinforced bottom end, the smart oil pump, depends entirely on one input: clean oil. The pump can increase pressure all at once under load, but it can't upgrade dirty, degraded oil into clean oil. If you're feeding it oil that's thousands of miles past its service life, you're asking one of the best engineered systems in this engine to do its job with a compromised tool. It won't announce itself with a warning light. It shows up quietly, as accelerated bearing wear you won't notice until it's already done damage. And by the time you hear it, the repair bill is a lot bigger than an oil change ever would have been. This is why you'll find two completely different stories about the same engine online, and both of them are true. One owner has 400,000 miles and says this engine is bulletproof. Another had a failure at 60,000 miles and says Ford dropped the ball. The difference? In the overwhelming majority of documented cases, isn't the engine, it's maintenance history. The high-mile survivors almost always have disciplined oil change intervals and used the correct oil spec for their climate and duty cycle, even when it meant changing oil more often than the sticker in the door jamb technically required. The early failures usually trace back to skipped services, extended intervals, or towing hard without adjusting maintenance frequency to match the load. It's rarely one dramatic event. It's usually a slow accumulation of small shortcuts that the engine's own toughness let the owner get away with, right up until it didn't. So here's what actually matters if you own one of these trucks, or you're about to buy one. First, stick to manufacturer-recommended oil change intervals and shorten them if you tow frequently or in extreme heat. Don't let the engine's reputation talk you into stretching it, because that reputation was earned by disciplined owners, not by the metal alone. Second, don't mistake over-engineered for maintenance-free. Those are two different things, and this engine specifically rewards owners who understand that difference and punishes, slowly and quietly, the ones who don't. Third, if you're buying one used, ask for service records before you ask about anything else. On this particular engine, a spotty maintenance history is a bigger red flag than mileage on the odometer, because a well-maintained Godzilla at 200,000 miles is often in genuinely better internal condition than a neglected one at 60,000, even though the number on the dash tells the opposite story. Ford built the 7.3 Godzilla to survive abuse most gas engines can't. The forged crank, the 6-bolt main caps, the load adaptive oil pump, none of that was accidental, and none of it is marketing exaggeration. It's genuinely one of the more overbuilt gas V8s on the market, designed by people who clearly wanted this engine to outlast the trucks it was bolted into. But overbuilt doesn't mean immune. The one variable Ford can't engineer around is what happens after the truck leaves the dealership, and that variable is entirely up to the person behind the wheel. If you found this useful, subscribe. I break down the real engineering behind these platforms, not just the marketing talking points. And I'm genuinely curious, what's your oil change interval on your Godzilla, and how many miles are you at? Drop it in the comments. I want to see how the pattern holds up across everyone watching this.